So we want to do a modulus function. We want to know how to redefine, how to find the domain and the range, at the same time how to sketch the modulus function. So I've got my first question here, which is f of x. Okay, let me not rewrite this question. This is my question. Okay, now how can I redefine this modulus function? So what is happening here is let's assume to say we have a function f of x to be equal to the modulus of x. Now to redefine the modulus of x, we do understand to say this is the same as just saying plus or minus. Now when we're saying plus or minus, when they say redefine, we have to put it in this wise function, meaning that I need to get the one for positive. I'm going to say I'll multiply it by a positive, so it's going to be positive. If it is positive, then this x has to be greater than or equal to 0. If that is positive, if I multiply this by a negative, then x has to be less than 0. That is the only principle which is there. So if I've got a modulus of 2, the answer always comes out as a 2. If I have a modulus of negative 2, it's going to be a 2. Now what is happening here is that for this guy to come out as a positive, we multiply it by a negative, so it is negative 2 times negative. I'm going to get a positive. So that's the principle which is there. That's the reason why we are saying plus or minus. Okay, now if you have got a modulus function and you are trying to define it, the one which you are going to do multiply by a positive, you have to, the same function, you have to get it and say greater than or equal to 0. So for x, next I'm going to multiply by a negative, that has to be less than 0. Then I've redefined my function. For example, this first question which we have here, which is just basically the modulus of 5x minus 4, I can redefine it and say this is the same as I'm going to get what is inside. So what is inside is 5x minus 4, meaning I've multiplied it by a negative, sorry, by a positive, comma, this 5x, for the condition is supposed to be 5x has to be greater than or equal to 0, because I've multiplied it by a positive. Now if I multiply this function by a negative, it's going to be negative 5x minus 4. Then now the same one, I'm getting the origin, this has to be less than 0 now, not less than or equal to, but less than 0. Then now what I have to do is I have to solve for x, for these guys, this and also this. So I'm going to solve for x. I'm going to have 5x minus 4 is greater than or equal to 0. 5x greater than or equal to, I'll shift 4 to the other side, it's going to be 4. I'll divide by 4, I'll divide by 4. So my x will be greater than or equal to 4 over 5. Okay, now I'm going to do the same with the second part, meaning I'm going to have 5x minus 4 less than 0. So what I'm going to do now is going to be 5x less than 4. I'll divide it by 5, I'll divide it by 5. X has to be less than 4 over 5. Now the next point I'm going to say, this is going to be equal to, I'm going to say this x, I'll get 5x minus 4. Now I've solved for x, I'm going to put this for the condition, comma, x has to be greater than or equal to 4 over 5. Next, if I multiply negative times 5, I'm going to get negative 5x. Negative times positive 4, I'm going to get positive 4. Then comma, the condition now is that x has to be less than what? X has to be less than 4 over 5. Now I have redefined this function. So this is what you can see here. I've defined my function. Before we go for sketching, you can ask questions.
Sir.
Yes, please.
Hello, sir.
Yes, yes. You have seen it? Perfect. Girls, let's try to ask questions. I know this is coming. Redefining always come. Sketching and redefining always come. So you have to know this. Uh-huh. Questions?
Sir,
Yes.
is doing solve the same if the same redefine and just for solving? Is solve it the same or when we say solve it's different from redefining?
It's different. Here we are just redefining the function because we know that a modulus, like in most cases, a modulus is the one they're going to ask you to define. So redefining, we know that a modulus is going to give us two things. So I can say that I have got my first part, which is this part, and the second part, which is this part. So I've redefined it. When we say redefine, we are trying to remove the modulus. So if I remove the modulus, the meaning of this function and the way it is here, it is the same. Is that okay? So it's different from solving.
Yes.
Yes.
Okay, sir.
Now let's try to sketch this. Sketching is going to be easy now because we have our condition. If you know how to sketch piecewise function, then I don't think you can have problems with sketching this. So remember, we have our function. Let me put it here. We are saying we have redefined this to be equal to 5x minus 4. X for x has to be greater than or equal to 4 over 5. Another one is negative 5x plus 4 for x has to be less than 4 over 5. Now I can just come up with simple coordinate here. Now when you are trying to sketch this, you follow the principle, or you follow the conditions which have been given. This is our condition for the first function. This is our condition for the second function. So I'll start with the first function. I'll put x, y. They are, say, they are saying that x has to be greater than or equal to 4 over 5. So I have to start from 4 over 5. If x is 4 over 5, what will be my value of y? So I have got my function which is 5x minus 4. 5x minus 4. If I put x to be 4 over 5, what will be my value for y? So 5 times 4 over 5 minus 4. We can clearly see that 0, 5 and 5 will cancel. I'll have 4 minus 4, which is going to be 0. Okay? Now, I'll go to the next one. I can go to 0 because 4 over 5 is approximately 0 point something, right? What is 4 over 5? Is approximately 0 point. I can go to 1. Any number which is greater than or equal to 4 over 5. I'll just go to 1. Yes, please. So I'll go to 1. If my x here, if I put 1 where there is x here, I'm going to say that it's going to be 1 times 5 is going to be 5. 5 minus 4 is going to be 1, not so?
Yes.
Are you sure? 5 minus 4 is 1, right? Yes, so I'm going to have 1. Okay. Next, I'm going to say if my x, we put another number. I can just choose 3. It's okay. Let me put 2. Kindly mute your mic. Temwani. Okay. So I'm going to put 2. If I put 2, it's going to be 2 times 5 is going to be 10. I'm putting 2 where there's x in this function. So 2 times 5 is going to be 10. 10 minus 4 is 6. I'm done. Next, I'll go to the second function. The second function, I'll put my another coordinate here, x, y. X is less than 4 over 5, but I'll start with the same 4 over 5 so that when I plug in the values, I understand to say when I say less than, I'm going to put an open circle at that point, meaning it is not included, not so? So I'll start with 4 over 5. If I put 4 over 5 here, it's going to be negative 5, 4 over 5 plus 4. It's going to give me 0. Next, any number which is less than 4 over 5, what number can we get? Any number which is less than 4 over 5?
-1.
-1. Okay. -1. If I put -1 here, what are we going to get?
-1 over 5.
No, 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 no. I'm going to get negative and negative will cancel. I'm going to have 5 plus 4.
9.
I'm going to get 9.
Yes.
Okay. I'm going to get 9. Okay. Next, what number can we put? Let's now get another number.
-2.
I can put -2. If I put -2 here, what are we going to have?
16.
16. It's okay. I can just end there. If you want, you can just choose 2 coordinates. It's okay. So I'm going to have my graph now. From here, I'm going to say this is my graph.
14, sir.
14. 2 times that one is 14. Yes. So I have 14. Now we can clearly see that in y-axis we have got 1, 6, 9 and 14. So I'm going to put 1 to be here, 6 to be here, then 9 to be here. I also have a 14. So we are saying this is in y-axis. I have 1, 6, 9 and 14. Then in x-axis I can see that negative side I've got -1 and -2. Positive side I've got 4 over 5, which I'm going to put it here, 4 over 5. Next we have got 1 and 2. Okay, now I can start. I'll start with the, yes please, you can just ask. Okay, so I'm going to start with this plotting now. I'm going to say what is 4 over 5, but since this one is x is greater than or equal to 4 over 5, meaning at that point it is included. 4 over 5 comma 0, it is at this point, but it is included. I'm going to put a crossed one. Okay, then where is 1 comma 1? 1 comma 1 I can find it here. Where is 2 comma 6? 2 comma 6 I can find it there. I'm done. Next, I can just connect these two guys to say that is my line. It's going there. Then I have to put an arrow because I don't know where it is ending. Okay? Now, I'm done with this part. I'll come now here. At 4 over 5, comma 0, it is open at that point. For that other guy, next, I have got -1 comma 9. -1 is here, 9 is somewhere here. I'll put a dot here. Then I've got -2 comma 14, which is somewhere here. Again, I can clearly see that starting from here, going there. That is going to be my. So this is my graph for f of x to be equal to 5x, the modulus of 5x minus 4. Then we are done for graphing, unless you have questions. Unless you have questions. Now, who can tell me the domain from the graph? Just you can get the domain. What will be the domain here? What? Yes, please. 4 over 5 included to infinity. Okay. Someone is saying 4 over 5 to infinity. That is our domain. Who else can try? What is our domain from the graph? The domain, these are x values. Yes, exactly. All real numbers. It's all real numbers because we can see that our graph here, we don't know where it is ending in x. It just keep on going there. Even here it keeps on going. But even 4 over 5, it is included. So it is all real numbers. What of the range? From the graph here, who can help us to find the range? The range, these are the values of y. So where is y starting? What will be our range? Come on, come on, come on. No. Y values, we can clearly see that it is starting from 0 going up. We don't have any y value to the negative. Yes, so it's 0 all the way to positive infinity. Yes, 0 to positive infinity, that is going to be our range. Is that okay? Then we are done. Question A. So you need to know how to redefine. You need to know how to find the domain and the range. You also need to know how to find um, or how to redefine. But redefining is very simple. But
With the question,
yes, please.
I've not understood how you found the range there. Yeah.
The range, okay? So do you understand the fact that the range, these are the y values?
Yes.
Okay, so from our graph here, my dear, we can clearly see that the range, even from here, just from these guys, we can see that y is starting from 0 going there, even here starting from 0. So from our graph, y is starting from 0 going to positive infinity. We don't have any value for y which is to the negative side, but starting from 0 going up. So that's why we are saying that the range is from negative or is from 0 all the way to positive infinity.
Oh, so I now understand because you can't like we know it's starting from zero, but we don't know where it's going to.
Yes, exactly. Okay.
Sir, I've got a question.
Yes, please.
What if they didn't say that we defined, they just defined the main the range and sketch the graph? What is going on?
Okay, yes. So now what I've just come to understand now is that sketching the graph for modulus, it will be easy for us to I can sketch this graph. Do you know that I can sketch without defining it? In case you don't know, we can do it now without defining it, and I can sketch this, and it's going to come out like the way it has come out here. Exactly. So but in most cases they know that that is going to be simple for you. That's why they tell you to say redefine. So do you want me to teach you how you can sketch this without defining?
Yes, behind. Yes.
Let me teach you.
Yes.
But if they ask you to redefine, this is what you do. You have first to remove the modulus, you put it in piecewise function, then you sketch it. Now without redefining, how can you sketch this? What you have to do, get what is inside the modulus. You just say 5x minus 4 equate it equal to 0. So for x, 5x is going to be equal to 4 divided by 5 divided by 5. So my x will be equal to what? 4 over 5. What I'm going to do now is I'm going to get two numbers. This is 4. This is 4 over 5. I'm going to get two numbers right, also two numbers left. What I mean here is this. If this is my x, this is my y. If I say two numbers left, what do I mean? The numbers which are less than 4 over 5. If I say two numbers right, the numbers which are greater than 4 over 5, not so. So let's get 3. Let's get three numbers which are less than 4 over 5. Which numbers are going to be? We can put negative, I can put negative 2, negative 1, even 0. Then now I'm going to put after 0, I can put, I know that 4 over 5 is approximately 0 point something. Then I can now put the same 4 over 5. Then now to the right side, I'm going to choose 1 and 2. Is that okay? Is that okay? Yes. Now what I'm going to do here is, this is my function. Remember, this is my function. So if I put negative 2 here, where there's x, what am I going to get? Let's do first. If I put negative 2 here, where there's x, it's going to be negative 10 minus 4. So what is negative 10 minus 4? Negative 14. But since it is in the modulus, that is going to be positive what? Positive 14. Now let's put negative 1. If I put negative 1 there, it's going to be negative what? It's going to be negative 9, right? But since it is in the modulus, a modulus will always give us a positive, so it's going to be 9. If I put 0, it's going to be negative 4, but since it is a modulus, it's going to be 4. If I put 5 over 4 over 5, it's going to give me a 0. If I put 1, it's going to give me a 1. If I put 2, it's going to be 10 minus 4, which is what? 6. Now I can have my graph. I don't know if you have understood how I've gotten y, the y values. If you have not gotten that part, please ask. It's okay?
Like that.
Yes.
If it was 5x plus 4, if it was 5x plus 4, would have multiplied it by negative or positive.
If it was
It was 5x plus 4 in the modulus there.
if in the modulus it was 5x plus 4,
Yes.
then you would have said x is going to be negative 4 over 5. So I'm going to get two numbers right and two numbers left. Or I say three numbers left, three numbers right.
Okay, and then what else when substituting the values of x? Would have multiplied it by negative or just like that?
Just like that, you just get the way it is. Don't multiply it with a negative.
Okay, thank you, sir.
Sure. So I'm going to put my, in x I can clearly see that I have got negative 1 and negative 2. Y, oh, here I've got 4 over 5, 1 and 2. Then in y I have got 1. I'm going to put 1 here. I have got 4, I have got 6, I have got 9 and 14. So if this is 1, this is 4, this is 6, this is 9, this is 14. Now we can do this. Negative 2 comma 14, it is at this point. Negative 1 comma 9, it is at this point, somewhere here. What else? 0 comma 4, it is at this point. What else? 4 over 5 comma 1, it is at this 4 over 5 comma 0, it is at this point. 1 comma 1, it is at this point. 2 comma 6, it is at that point. We can also clearly see that this graph will be like that, going here on that they are supposed to be in a straight line. Is there any difference? This is supposed to be somewhere here. Is that any different? I have sketched this without redefining the function.
So, Sam,
Yes.
how if you use this method, how do you know that this point it was open, then the other point was closed?
No, initially, even that other one, because you are going to have a point where which is going to be open, another one is going to be closed. So even if you don't show this, because that part is already included.
Okay.
Yes.
This
So without redefining, I can also sketch this. But me, I see redefining as a simple thing. You first have to redefine it and sketch. Okay, but this one you can't do it direct without redefining. Question B. This is the most interesting question. You have to know this. So what I'm going to do now here is this. For B, this is what I'm going. I have to redefine in such a way that I have to redefine this first, again that, but there is a minus. Now I'm going to show you how. We first have to redefine the first part. To define this first part is going to be like this. 2x minus 1 is equal to, is going to be for 2x. If I multiply by a positive, this 2x minus 1 has to be greater than or equal to 0. Then another one I'm going to multiply by a negative. For 2 plus x, for 2 minus x, sorry, has to be less than 0. Now I have to solve for x for these guys. And I'm going to say, I'm going to have my 2x minus 1 greater than or equal to 0. So 2x will be greater than or equal to 1. Then x will be greater than or equal to 1 over 2. I don't know if you're confused on how I found 1 over 2. You're okay there? Are you okay on how I found 1 over 2? I'm going to get this as well. I'm going to say 2x minus 1 less than 0. 2x less than 1 divided by 2 divided by 2. X will be less than half. Then this is going to be my final function, will be like this. For 2x minus 1, x has to be greater than or equal to half. This one now. Next, I'm going to multiply by a negative, which is going to be negative 2x plus 1. For x has to be less than half. I'm done with redefining. For the first part only, I'll get rid of this. Then I'm going to say the second part, which is x plus 2. To redefine this is what I'm going to do. For x plus 2, I'm multiplying by a positive. Then for this guy, it has to be greater than or equal to 0. Next, I have to multiply by a negative. For x plus 2 has to be less than 0. Now I have to solve for x. Let's solve for x for these guys. I understand to say it's going to be 2 plus x plus 2 greater than or equal to 0. So x will be greater than or equal to negative 2. Another one is going to be x plus 2 less than 0, meaning x has to be less than negative 2. So I'll continue it from here and say, yes, please.
So the negative sign between the two moduli, should we just ignore it?
Yes, we are going to ignore it for now, but we are going to come and subtract these two guys. And that's where I'm going.
Alright.
Sure. So I'm going to say these two guys, now I can clearly see that I'm going to have x plus 2. I have already solved for x has to be greater than or equal to negative 2. Another one, let me put it there so that people should not be confused. Let me just do this. For this one, we know that it's going to be x plus 2. We have already found the value of x. For x has to be greater than or equal to negative 2. Next, if I multiply this negative by this, is going to give me negative x. The negative times positive 2 is going to be negative 2. For x has to be less than negative 2. I'm done with the second part, redefining now. Before we go to the next step, any question there on how to redefine a function? No question, right? Okay. Since there is no any question, before we continue, do you want me to still advertise for Transcended, or you want us just to be solving?
We solve. We have your number, sir.
We no, as usual. For those who don't know about Transcended, it is high time for you to know how to redefine function. Now that you have understood on how to redefine a function, next time you need to know binomial, you need to know trig, you need to know calculus, the longest topic in math. What you have to do is just register with us and you'll be able to access all the videos, all the videos for math, okay, including the detailed explanation on how to redefine a function using two methods. This is just one method which I'm giving you here, okay. So since you are saying you have my number, for those who don't have my number, here is my number. Uh, 0767729927. So you can WhatsApp me using this number. Anyway, let's continue now. So now we are saying we are done with redefining a function. Now we have to go to the second step. Are you guys okay on how to redefine a function before I go to the next step?
Yes.
Okay. So let's go to the next step. Now the next step, since there is minus, we need to add this. There is minus, so we need to subtract this guy and this. But how do you subtract these two guys? This is what you are going to do. Allow me to shift this to be just on top just a bit. Oh, what can I do? What I'm trying to do here is, okay, let me just put here. I can even put it here, right? Or I can go to the next page. Why am I even struggling myself? So this is what I'm going to do now. Let me show you. I'm going to have this. This is more like an inequality now. I'm going to have this. So I have my critical point at what? I have my critical point. What are my critical point? I can see that I have got half and negative 2. So which one am I going to write first? I have to write negative 2 here. Here I have to put 1 over 2. Now, for this part here, okay, I'm going to have this. I'm also going to have this. For the first part, we can clearly see that this guy here is saying we have negative 2 and half. These are just critical points which I've just put them here. Negative 2 here and this. Okay. Now, Let's see the conditions which we have for negative 2. X is telling us that X has to be what? We clearly we know, guys, that when I go this side, is X greater than 2 or less than 2? When I'm going to the left hand side, do we expect X to be less than 2 or greater than 2?
Two.
To be less than or greater than?
Less than two.
So I'm going to say here X is less than 2. So this is less than 2. Okay? Now, for the guy in between, before I come here, now what about this? I'm going this side. Do we expect X to be less than or greater than 2? From here, greater than. But since the greater part here, the one which is having is greater than or equal to, I'm going to put X has to be greater than. So I'm going to say my X here, I'm going to put to say X has to be greater than, I can say greater than or equal to half. Okay, for this part. Then for this part, if you want, you can just put it here. It's okay. I can say for this part X has to be less than negative 2. Now for the guy in between, we know that X is less than what? Negative 2. Okay, but again X has to be greater than or equal to what? Half. Do you understand the fact that if I can put this guy here to say, let me first go here, I have got my X to be less than half, but at the same time X has to be greater than or equal to half. These are the guys which we have not used actually. So we have got from negative 2 has to be less than or equal to X, but X has to be less than half. This is the guy which I have to put in between. What it means is that my X is greater than negative 2, but at the same time my X has to be less than half. That is inequality now. So here I'm going to say X has to be less than or equal to X, at the same time X has to be less than half. Then I'm done. The way I've put those guys on top, are you still having some challenges before we go to the next step?
I'm not understood. Fine.
Okay, let me do this. Do you understand the fact that we have got two critical points? Our critical point is X should be equal to negative 2 and X is equal to half. From here, this guy and this guy, negative 2. Is that okay?
Yes.
Then now next, what I have to do is I need to make a table. So this is my table. Now this table, we know that we have to put the critical point. So the critical point which I've got a negative 2 here and 1 over 2. But we know that less than this, meaning X has to be less than what? X has to be less than negative 2. Then here X has to be greater than or equal to half. I'm just following this. I'm just getting this now. I've gotten this part here. For X has to be greater than or equal to half and X has to be less than this. Now I'm remaining with this and this, which I have to put in between. Another one is saying X has to be greater than or equal to 2, but another one is saying X has to be less than half. So it's the one which I have to put it in between here. So X is greater than or equal to negative 2. At the same time X is less than half. What does it mean? The values, they are starting from negative 2, less than or equal to X, but X has to be less than half. This is the same if I get just this part. If you attended my inequality class, I said this is the same as if I say negative 2 is less than X, it's the same as X is greater than or equal to negative 2. So I'm going just to put this part in between. Then I'm done. I'm going to say less than or equal to X then x should be less than half. You have seen,
Yes, sir.
yes. Then now next, what I have to do now is I'm going to do this. The modulus which I have, guys, I have this part. I'm going to get this part here. The way it is with the modulus 2x minus 1. I'll come here and say 2x minus 1. I put it in modulus. Next, what do I have? I have x plus 2 in the modulus. I'm going to put it here, x plus 2 in the modulus. You get my point, eh? Now, remember, I don't know if it is important for me to do this. Let me do this, because you are a bit confused. Let me shift this one to be on top. I'll just do this. Okay, then I want to put the ones which we have just redefined. Is it okay if I can put it here? The first one, I put it here. Those who were writing, please help me. We said 2x minus 1 for x is what? Is greater than or equal to half, right?
Greater than or equal to
Another one, we said 2x plus 1 for x is less than half. We are okay there, right? The ones which we have just redefined. Now I'm going to put another one there. This was for 2x minus 1. This one. Now what about for x plus 2, the one we put it in modulus? What we had, x plus 2 for x was greater than or equal to negative 2. Another one was for negative x minus 2 for x is less than negative 2. We are okay, eh? This is what we had. Now here is my table. What I have to do is, in the first guy here, this is my first guy where I have 2x minus 1. So now here is saying x has to be less than negative 2. Which function here is telling us that x has to be less than negative 2? Is it the first one or the second one? I have got the first one is this part, the second one is this. Now among those two guys which I've just circled, which one is giving us the information that x has to be less than negative 2?
the second one.
The second one, yes. So I'm going to put the second one. Okay, I'm going to say this is going to be negative 2x plus 1. I'm done with that table. Next, I'll come to this one now. Which one is telling me that x should be less than negative 2? I have got this and this. Is it the first one or the second one?
Second one.
The second one. So I'm going to put the second one here to say negative x minus 2. I'm done. Now I'll come in between here. I'll go back to this. From my first function which I've just redefined, which one is telling me that x should be greater than or equal to negative 2, but at the same time x should be less than half? Is it the first one or the second one? The first one? The first one is saying x should be greater than or equal to half, but the condition is that x should be greater than or equal to negative 2, but at the same time x has to be less than half. So is it the first one or the second one?
Oh, has to be
Second one.
done.
The second one.
Second one.
Yes. So I'll come to the second one, 2x plus 1. I'll come to the next table. Hey. Yes. Those having questions, please ask. How we did what? This one. We are saying that for this guy, for this function which you have here, which one is telling us that x should be less than negative 2? Is this one. So I've gotten just this part, x minus negative x minus 2, because the condition is that x should be less than 2, negative 2.
Thank you.
Sure. Now, for the second part, which is this part here, which one is telling us that x should be greater than or equal to negative 2, but at the same time, x should be less than half. Is it the first one or the second one? Here. Is it the first one or the second one? X should be less than half, but x should be greater than or equal to negative 2. Which one? The what? The first one. So the first one, I'll put it here. I'm done. Now I'll go to my last part here. From the first guy here, which one is telling me that x is greater than or equal to half? It is the first one, right?
Yes.
So 2x minus 1. I'll also come here for this guy. Which one is telling me that x should be greater than or equal to 1 over 2? Is it the first one or the second one? X should be greater than or equal to 1 over 2.
First one.
The first one.
First one.
I'll come here. After doing this, the original function was 2x minus 1. We had the sign here. Let me go back here. The sign here is minus. Okay? Since this number you have already gotten it, the sign here is minus. So I need to do minus here. What I mean is this guy minus this. At the same time, this guy minus this guy minus this. So this is what I'm going to do. I no longer need this part here. I can get rid of it. This question came last year. Final exam. It had about 8 marks.
Oh,
So I'm going to say the first part here, I'm going to say I need to put them in brackets. I'm going to say negative 2x plus 1. I need to say minus because there is a minus here. This question here, there is a minus here. If there is plus, like in this case, I need to put plus. But since there is minus, I need to say minus. So I'm going to say minus. These ones I need to put them in brackets as well. Minus negative x minus 2. What is the condition? The condition is that x has to be less than negative 2. Then I'll come here again. Here I have got negative 2x plus 1 minus x plus 2. I'll put the condition. The condition is that negative 2 is less than or equal to x, but x has to be less than half. Next, I'll come here and say 2x minus 1 minus x plus 2. The condition is that x has to be greater than or equal to half. Now I have to simplify this. There is a lot to do. Have you seen? I'll come here and say I no longer need this. I'll come here and say this is going to be like this. Now I can open the brackets. So the first one, if I open the brackets, I'm going to have 2x plus 1 minus plus 1. Then that negative is going to affect everything. Negative x. Then I'm doing this negative times this. Again, this negative times this. Okay? So negative x, then plus 2. The condition is that x should be less than negative 2. Yes.
supposed to be negative x or positive x?
Oh, this is supposed to be positive. Thank you. Because negative times negative is positive. Next, I'm going to say, let's be observing the mistakes. Next, I'm going to go to this guy. I'm going to say negative 2x plus 1. Negative times x is going to be negative x. Negative times positive 2 is going to be this. For the condition is that negative 2 should be less than or equal to x. Then less than half. I'm now here. I'm going to say, I open the brackets. Negative, and that guy is going to give me negative x, then negative 2. For the condition x has to be greater than or equal to half. I no longer need this, unless you have questions. Now I have to simplify this. I can clearly see that my final function is going to be this guy, and this guy is going to give me what? Negative x, right?
Yes.
So I'm going to have negative x. Then this guy and this guy, I'm going to get positive 3. The condition is that x is less than negative 2. This guy and this guy, I'm going to get negative 3x. This guy and this guy, I'm going to get what? Negative 1. The condition is that negative 2 less than or equal to x, x is less than half. I'll come here. This chap and this chap, I'm going to get what? 2x minus x is what? Is x. Then I have this, and this is going to give me negative 3. The condition is that x should be greater than or equal to half. This is my final function. Now I've redefined. So redefining, I'll end there. But I have to sketch that and find the domain and range. Is that okay? Now, I'm not done actually. I've just redefined this function. Now, so you do this. The defining, you write it like this. You are going to say, for me to redefine this, I have got, what was the function? The function was 2x minus 1 minus, I have also had x plus 2. This is equal to, redefining this, we have found that negative x plus 3 for the condition x is less than negative 2. Negative 3x minus 1 for the condition negative 2 less than or equal to x less than half. Another one, x minus 3 for the condition x is greater than or equal to half. I've redefined now. I'm done. So redefining only, I'm done. This is what I'm going to say. I'm done. Now I have to sketch. Yes.
What you've just written in white is what was in red, right? Or you have
Yes. No. What I've written in white is what is in red. I've just copied exactly the way it is.
Alright.
Yes. Now I have to sketch this. But sketching this, I need first to find the coordinate. I'll start with the first function. This is my first function. This one here. You follow the condition which you have here. The condition that x for that one should be less than negative 2. But we're going to start at that point, but we're going to put an open circle. So I'll start here and say x, y. If x is negative 2, I'll just get 3, 3, 3, that's all. If x is negative 2, if I put negative 2 where there's x here, what will be my y? So it will be negative 2 times negative, negative 2 times negative 1 is still positive 2. It's going to be 5, eh?
Yes.
I'm talking about this in case you are confused. Negative x plus 3. If here we put negative 2 plus 3, we are going to have a 2 plus 3, which is 5. Next, any number which is less than negative 2, I'll pick negative 1. So if I put negative 1 plus 3, then it's going to be 1 plus 3, which is what? 4. Next, I'm going to pick 0. If I pick 0, it's going to be 0 plus 3, which is going to give me 3. I'll end there.
Sir, you said that you're getting something that is less than.
Oh, sorry. Less than, yes, and I'm getting greater than here, and you are just watching me. From negative 2, I have to get what?
Negative 3.
Negative 3? I need to get negative 3. Yes, 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 yes. So now I have to pick negative 3. If I put negative 3 there, what am I going to have? I'm going to have 6, not so. I'm going to have negative 3 plus 3. So 3 plus 3, 6. Yes, that's correct. Let's get another number less than. A number which is less than this again, let's get negative 4. If I put negative 4, it's going to be 4 plus 3, which is going to give me a 7. I'll end there. Is that okay? Or you are still confused? We are okay, right?
Yes.
Now I'll go to the
Okay.
next one. I'll go to this guy. Now this one, they have given us the condition that x should start from negative 2, ending where there is what? Half. So I'll not struggle. I'll have my another x coordinate here. Here they're just telling me that from negative 2, I have to go to negative 1, I have to go to 0, and I have to go to half. As simple as that. This one, they have given us where to stop and where to start. We are starting from negative 2, we are ending on what? Half. Have you seen? So the numbers in between. So if I put negative 2 here, it's going to be negative 3, negative 2, minus 1. So it's going to be positive 10 minus 1, which is what? 9. We're okay?
Yes.
It's 9, ka? It's 5. Oh, it's 3, not 5. Ah, the third is that. So negative 3x minus 1, where there is x, we put negative 2. So it's going to be 6 minus 1, which is 5. Yes. Those having questions, please ask. Let's put negative 1. If I put negative 1, where there is, I'm going to have positive 3 minus 1, which is what? 4. 2.
Two.
If I put 0, negative 1, right? Then if I put half, so I'll have negative 3 times half minus 1. Negative 3 over 2 minus 1. This is the same as negative 3 over 2 minus 2 over 2. So if they didn't, because this is the same as 1, the one I've circled there. But if you want, you are confused, you can use the common denominator. It's okay. So now what I'm going to have here is negative 3 minus 3 is going to give me negative 5 over 2. So negative 5 over 2. You are confused. Here I can find the common denominator, which is 1. 2. 2 into 2 is 1. I'll have this. 1 into 2 is 2. 2 times that one is this. So I'll have negative 5 over 2, which is the same as the one I found. I'm done with the function which is in between. I have to go to the next. I'll do it from here. This one I'm going to get just 3. Starting from half, they are saying if x is half, what will be the value of y? If x is half minus 3, it's the same as here there's 1. I'll do 2. 2 into 2 is 1. 1 times 1 is 1. Minus 2, 6. I'm going to have negative 5 over 2. Is that okay? Any number again greater than or equal to greater than half, I can get what? I can get 1, right? If I put 1, I'm going to get negative 2, not so. If I put 2, I'm going to get negative 1. If I put 3, I'm going to get 0. Let's end there. Now I have my coordinate. I need to come up with my graph. In x-axis, we can clearly see that we have got the negative ones. They are starting from negative what? Negative 1 all the way to negative 4. So negative 1, negative 2, negative 3, negative 4. So I've got -1, -2, -3, and -4. To the the positive side, we can clearly see that it is starting from from half. So I'll say this is my half. I also have 1, I also have 2, I also have 3. That's all also. Then to the y side, I can clearly see that I have got the negative. Let's start with the negative part. The negative part, I've got -1, I've got -1, but I also have -2 and negative what? -5/2. Is that okay? -5/2 is greater than -2. In short, it is less than. Okay. So now, what I'm going to do now is the positive part. What do I have? The positive part. Can you see the positive part? The positive part of y. You check both. I have got what? Do I have 1? No. But I have 2. What else? Do I have 3? No. Do I have 4?
5, 7.
I have 5, 7, or 5, 6, and 7. So I'll say I have got a 2, 5, 6, and 7. Now we can have our graph. Let's start with the first guy, this guy here. What is -2, 5? -2 is here, 5 is somewhere here. It is at this point. Next, what is -3, 6? -3, 6 is somewhere here. What else? What else do we have? -4, 7. -4 is there, 7 is somewhere here. What else do we have? Now we are supposed to put another value here. But if I want, since I know that this part here is going to be, is it going to be open or closed? It's going to be open. But again, at the same point, there is another guy which is starting here. So I don't have to worry with that. I'll come now to the second part. The second part is telling me that -2, 5. Where is -2, 5? -2, 5. Again, it is at the same point. Okay? So the first one is going to be open, but this one is going now to start with a closed one to show that it is included inside there. Next, I'm going to have -1, 2. Where can I find -1, 2? It is at this point. 0, -1. Where can I find 0, -1? It is at this point. It's now making sense. Let me use yellow. It is at this point. Where is half? Where is half, what? Where can we find half, 5/2? This point, somewhere here. Okay, yes, at this point. I'm done with that point. Now I'll go to this and say, where is half, -1/2? It is at the same point now. It is starting at the same point. But since it's going to be included, I'm going to put an open one. So I'm just, this one is supposed to be open. Another one starting from there has to be closed. It's just a connection. Then 1, 1 in x, then 2. It is at this point. Exactly. Then I'll say 2 in x, -1. It is at this point. Then 3, 0. It is at this point. So we can see that it's going to be going like that. So my graph is going to be like this. Which color? Let me use white, or let me use this color. It will start from here. When reaching at this point, it's going to turn like this, coming there, again going there. But I have to put the arrows because I don't know where it is ending. So this is the graph of everything there. Now from here we can get the domain and range. What is our domain?
Sir,
Yes.
uh, the point where the graph is passing on the negative
Yes.
part of the x-axis,
Yes.
is it
Is it what? You can ask again. I've not gotten your question. Okay, I've not gotten your question. What are you saying? Anyone having a question there? Are you guys getting me?
yes?
Yes. I don't know if maybe the network has dripped. But now this is the graph. Now what is our domain in this case?
All your numbers.
All real numbers. What is the range? Now I want a girl to tell us the range. What will be our range? The y values, remember? What will be our range? Hmm? The y where the y, just check the y where it is starting. Where it is starting from. The y is starting from where?
From was negative 5 over 2
It is
to
included 5 over 2
positive
infinite.
infinity.
Yes, that will be our range.
Yes.
I believe now from the principle which I've given you, the reason why it is to the negative side, I don't know. I was expecting someone to ask to say, why is it that it is modulus but it is to the negative side? The reason is simple, because I have got a minus here. In a case where you have this, let me show you this. The positive, like this guy here, this question, it is a positive. It will go direct to the positive. So you go ahead and follow the same principle, go and solve this.
Which question, like in an exam, because like I think the quiz is only 1 hour. And,
The quiz, sometimes they can give you this. It's just dialect. But in your test, this question is coming whether you like it or not. Maybe they can give you this, but they can give you. It's possible. And there is no any other method apart from this one. Namara. Namara is-
okay,
Yeah, there is no any other method apart from this one.
I thank you.
So what are we remaining?
Sir, me I've got a question.
Yes, please ask.
Sir,
Yes.
how on the shan on the range? How did you know that the negative 5 over 2 close?
Or how did we know that it is included? Eh?
Because then
Yeah, because it is not jumping. We can clearly see that there is another one which was just open, but another one came in and then it was included. So like the way it is, this part here, it is included. It is not jumping, and that's the reason why we have said that the domain is all real numbers.
I'm not asking about okay, anyway, you've been clear to the range. I was asking about the range because if they are on negative 5 over 2.
Okay, we had a point, we had a point -2. Okay, it's here in short. We had a point, half is the one which was giving us -5 over 2, not so, for the last part. But now since x is greater than or equal to half, so if I say greater than or equal to half, meaning this half is included, meaning that even the y, the one I'm going to plug in here, it is also included. So I follow this. I'm following just this. If this was x less than, yes, yes, if it was less, if it was just greater than half, then -5 over 2 would have not been included.
It would have been included.
Yes. Then the domain, The domain would have been changed now. Okay, so we end there. I think this is
Wait,
ooh.
you said that the domain would have been how?
the, domain,
Would have been what?
the domain would have been jumped now because it is not included. So the domain would have been from negative infinity all the way to half, then union half is not included because if this was just x to be greater than half, meaning half was not included in that case.
Was not included.
Yes, so it's supposed to jump now from there, then I say from half all the way to positive infinity. So you have to go through this, you have to get the concept. It is very, very important, and you have to know this. So
Wait. For the answer, we can send on that WhatsApp number of yours.
yes, you can send it in the group.
Okay.
If you're not comfortable with sending the answers in the group, you can send it. You can send the answers in my inbox. It's okay. Okay. Good night.